Hey everybody, welcome to our weekly show and anything to do with AWS networking called the Routing Loop. My name is Tom Adamski. I'm a solution architect focusing on networking. I have a guest today who's also a regular of the show, one of the moderators, Jamie. Jamie, you want to do a quick intro?
Yeah, my name is Jamie Wenzel. I am a principal solutions architect working on the service team where we make all this fun stuff. And of course, good friend of Tom's and a moderator of the show. This is actually one of the first times we've done a show together in a while, isn't it?
Uh, Probably. I feel like we've done a few in the past, but we've done this for so long that it just
Yeah,
feels like we've definitely done it before. But I can't remember if we did one where maybe we done when I was the presenter and you were my moderator.
I think so. Yeah, I think this time the shoe is on the other foot. So yeah, you
Yeah.
get to crack the whip.
Yep. So for everyone's information, we're in the application networking series season right now. We're going to have 4 shows that are focusing on application networking. And the big building block of application networking is Amazon VPC Lattice. We did a session last week. It's available on demand on the routing loop. I'm going to post a link to the video in a second in the chat. But we're continuing with the series. Jamie, you want to tell us what you gonna have for us today?
What's on the menu?
What's on the menu?
Yeah, so today I'm going to be going over a lot of architectures. So a lot of architectural diagrams. Basically, we're going to be building on top of what Tom had talked about last week. I'm going to reiterate some of those things. I think I have that in some of my slides. Also, I'm going to be very candid. Tom and I are working on kind of like a roadshow thing to present around the globe. So I am breaking in some slides. Some of them are special for you, but some of the other ones are also more generic. So if you want to give me feedback saying, hey, Jamie, some of these slides are confusing, or I like the way this looks, or do more of this, or, things like that, that's perfectly okay. But yeah, just going to go over like the art of the possible, if you will, with VPC Lattice and endpoint services. Because as you explained last week, endpoint services brings TCP to the yard.
Yeah. So I guess we've set the fundamentals, and we will probably do a little bit of overlap, right? Not everybody
Yeah.
was able to maybe saw the session last week, so we'll probably recap some of the things, but we're going to anchor the session today mostly in use cases. So how can you use VPC Lattice? Where do we see it being applicable?
And I am using most of, or just about all of the architectures I'll be showing today. These are architectures that customers or I've helped customers design. I do have their permissions to use them, but I'm not going to be mentioning what the customers are or what the workloads do. We're just going to be focusing on the connectivity and why they need that connectivity.
Cool. All right, Jamie, I'm gonna give the stage to you.
Okay, so let's pop it up.
Who is this handsome fella on
Who
the
is that
screen?
handsome fella? Yeah, of course, it's Tom. Just for context, Tom and I did a reinforce a while back where we both used our bit emojis. I did not include mine in the deck because I am not as handsome as Tom. So
I
to
think
get
those were
things,
the days. It's very generous in terms of how much hair I have. So I thank you for that, Jamie.
I was not going to mention that. I promise. I was like, I will not make fun of my friends on live streams. I have to repeat that over and over and over again. All right. So last week, as we mentioned already in the intro, Tom had covered endpoint services. He went a little bit in depth in the fundamentals of how this all works, how the things get put together, kind of like the Rube Goldberg machine under the hood of connectivity, endpoint services. And again, I'm going to basically cover those a little bit again, but I'm not going to go so far in deep as Tom did on the functionality. Mine's going to be more related on how does this work with the architecture that we're going to be talking about. So that's kind of the difference of what we're going to do. The other thing too is, again, if we finish and there's enough time, or if anybody has some questions, I do have a whiteboard open. We can whiteboard things if I don't have slides already. One of the other things too, I just want to mention real quick, I'm not going to be covering the roles and policies. Tom did a great job of covering those. And that takes up a lot of time, a lot of space, and it won't let me kind of get into talking about the architecture. So that's going to be implied, if you will. I might mention it once or twice, but I don't have any slides on that.
Trying to adjust to your character and seeing if how close do we resemble each other. I think it was
Let's see.
pretty,
Let's see. You got
yeah,
to turn your head to the side.
yeah. I think that's
There you go. Perfect. I'm going to be keeping this, by the way, forever, just so you know that.
yeah.
All right. So first thing we're going to do though is we're gonna do a little bit of elephant in the room things. We're going to talk about Lattice versus Transit Gateway, and the main reason why I'm bringing this up in an architecture's diagram or an architecture's conversation is I cannot tell you how many times when I talk to a customer who's savvy in AWS, they're like, well, what would I pick? Which one is better? And they do a lot of verses. And there are times when Transit Gateway and VPC Lattice are verses, but there are times when they also overlap. So let's kind of like dive in a little bit to this. So if we're looking at Transit Gateway, right? Basically, it's a networking service for connectivity. You're connecting networks to networks, right? Routing, scalable, efficient, all of that. It's basically a VPC to VPC centralized networking core. And it also does, VPN. It does Transit Gateway Connect for SD-WAN, right? It also does Direct Connect, and it's very centralized. But again, the paradigm for that is network to network communication. But when you're looking at VPC Lattice, it's service to service communication. So what we're doing is we're basically connecting those services together in a service mesh. It has built-in security. It has built-in observation.
Probability.
Thank you. I don't know why I'm getting tongue-tied on that, on observability, but on observability, all that stuff is kind of built into that service, like what you would expect of a service mesh. The thing to keep in mind too, though, is that VPC Lattice is a big proxy, right? So it does a lot of proxy app networking things. So service communication, service discovery. There is a Alex will probably be showing you next week. She's going to be doing a demo of the service of like the service discovery screen with all the services listed and how you can easily copy and paste those in and out. But this pretty much operates at layer 7, or originally operated at layer 7, and now with service endpoints, which we'll get into, we can do a little bit of layer 3 and 4 as well. I did get cooked a little bit, and when I did my reInvent presentation on the video I noticed on YouTube, I had made a mistake and said Transit Gateway was layer 4 right after addressing private link, and everyone's like, it's 3. I'm like, I get it, I know it's 3 and 4, but I'm sorry. I got a little tongue tied. There's like 400 people wanting me to make them happy.
And I don't know, Jamie, if you're going to be touching on it, but we had this question last week about, and I think Matt picked up on it. Is it Transit Gateway and Lattice, or is it Transit Gateway or Lattice?
I do pick up on that. That is a good feeling. One of the use cases actually uses the Transit Gateway and Lattice. So we'll be talking about that. And then also, please, again, for everyone who's watching, feel free to interrupt. Tom will be more than happy to stop me from yapping. Or Tom, of course, if you want, if I need to make a point that was not fully made last week, just let me know. All right, so we're going to take a look at Transit Gateway, right? Right here, we have 4 VPCs. Of course, it could be up to 5,000 VPCs centrally connected through Transit Gateway. And in this configuration, I'm trying to make them as closely comparable as I can to each other, Transit Gateway and VPC Lattice. So again, just to kind of go over the Transit Gateway use case, central communication, all communication is bidirectional, right? Any type of security you're going to do in Transit Gateway is going to be on the perimeter, your standard network type stuff. You got your firewalls, you've got your security groups, things like that, right? But some of the things that Transit Gateway does that VPC Lattice won't do, overlay networks, ECMP with VPNs, Direct Connect. You got your SD-WAN with Transit Gateway Connect, right? It supports cross-region peering. Remember, VPC Lattice is a regional construct. And for the purposes of all the architectures going forward, let's consider them all in the same region. I don't have it highlighted because I only have so much real estate to put icons. But so that's Transit Gateway kind of in a nutshell.
So
and then if
an analogy, sorry, Jamie, to interrupt, but an analogy of a Transit Gateway would be on-premise would be kind of a router, right?
Right.
It's not a single device, obviously, in the cloud. It's a distributed system, but if from a functionality point of view, you can imagine it as a logical router in the region, and you create interfaces to your VPCs, and then you can route between those. So it's kind of like opening up network-to-network communication.
Right. Just basic core networking principles, right? So then if we're looking at VPC Lattice, VPC Lattice is more of a application networking construct. It is a large proxy. It allows you to connect services together in multiple VPCs. And that's where some of the overlap comes in, right? Because with Transit Gateway, if you really, really want to, you can set up the routing to a bunch of ALBs, as you saw in the past. The image will come back up again, and you can get those different services to communicate, but you need to have something like a proxy or whatever in the way. This will help you distribute load. This also does load sharing not only within the target groups of your individual services when you set up a service, but you could also distribute your load to each service. Like in this example here, you'll notice that the two top services are service A. So this could be something like a migration. It could be splitting it between two different VPCs. One caveat, though, is if you're doing multiple account sharing, as Tom described last week, that you can do multiple accounts with VPC Lattice. If you're going to be doing load sharing, it has to be done within the same account. You can't load share between two different accounts. So I didn't ask that one before. So then a couple of things that you can do with this, as I mentioned, traffic distribution, the service discovery piece, which we'll harp on Alex to show you next week. You can have all the services that are shared with you, the ones that you're sharing and the ones that you have in a single pane of glass that both your network administrator or service network administrator and your service owners can get access to and add into their code. The policy, as Tom described last week, the policy-based security is more or less organic. You have a service network policy that's set, and then each individual service sets their roles and their individual policies. And as they grow, it's up to the service owners. It's the way it is designed to keep setting those. So you don't have to go back as a network administrator and relock everything down all over and over again. Application-based routing, again, within those policies and roles for what your services are, it could be determined based on what others want to accept based on those roles. That not only has a permission base, but also sets up a routing base over the routing layer. Because remember, when you're sending traffic from one service to another service over VPC Lattice, even if those VPCs are also connected to Transit Gateway, the data is not going over your Transit Gateway. You're not doing that 2 cents per gig out. You're going over the processing charge of VPC Lattice, right? So it's going to take a different path. And then, of course, you can get per request metrics and logs because, again, it's a proxy. So your access logs, all of that stuff that you're used to, say, with an ALB, you can get the same type of information out of VPC Lattice. So if you're looking at Transit Gateway, you're going to be doing like VPC flow logs, right? And you're going to be looking at the logs from Transit Gateway. Access, is it allowed? Is it not allowed? What are the pairs that we have set up? And with VPC Lattice, it's more of like, hey, was this header dropped? Or what was the, was this accepted going through my access log? Who came in? All that kind of metrics. And again, as we always say, and as Sid will always tell you, make sure you put all that data in a large data lake so you can look at it with your SIM or X-ray or all that fun stuff. Don't use it in disparate places because then troubleshooting will be a big pain in the butt.
Yeah, Jamie, there's a slightly longer question here. I want to kind of bubble up from Karim. When we were talking about differences, and I hid you a little bit behind me. Let me move you up.
That's okay. That's okay.
So the major differences between kind of Lattice and Transit Gateway, Karim makes an interesting point here about like requiring more knowledge about the applications themselves, right? Because if you're setting up a Transit Gateway and a Transit Gateway network, you just set up your pipes and you're done. Whereas with application networking, you're exposing individual applications, so you have to have knowledge of what is the application that you're exposing. So I think this is a really good point.
That is a great point.
Yeah, but I think where it's interesting, and curious about your opinion, Jamie. But
Sure.
The interesting thing for me is probably different teams are dealing with these concepts, right? Because if you just have a networking team that is tasked with, hey, set up piping for me and I'm done, then the application team, when they're deploying an application, they still have to register it with a network load balancer, an application load balancer. They still have to, once they register it, they need to figure out what the host name is going to be, and then have to tell everybody about that host name. So you have the networking team that doesn't really have to care about the applications, but then the application team now has to care about a lot of things to figure out how do I expose my application to the rest of the world. Whereas on the application networking side, on Lattice, you're kind of allowing the application team to immediately register their application to the networking construct that is already enabled everywhere, right? So yeah, and we have integrations. I think the big one that we talked about in the past was the Kubernetes integration, where you can deploy an application in Kubernetes and automatically register it with Lattice through the Gateway API, and then just becomes available through Lattice. You still have to make sure your DNS is configured and that people know what DNS to connect to, but you kind of just combined both things into one component rather than having these disjointed. Okay, networking has to figure things out. Then I have to set up my load balancer anyway. Then have to set up security groups with the transit gateway. So what are your thoughts on this, Jamie?
So the thing is about this that I've seen is that, and I've had a bunch of conversations on this, right? Um, One thing is that you have to have trust, right? If you're going to be doing application networking where you're involving your development team and your networking team or DevOps team, whoever is going to be in control of the service network versus those who are going to be in control of the services, there has to be a line of trust there. I have seen in some organizations, because it does exist, where there is absolutely no trust on anyone. And believe it or not, the team that is driven crazy the most after they do Lattice is the InfoSec team, because they're the ones chasing down all the service owners because of the different policies that they're setting on their own services. So the first thing to say right off the bat is, and I ask them is like, do your teams trust one another? Is there like, hey, if you have a service owner, and will you allow them to set their service policies? That's not to say that the service owner, I said service, yeah, service owner. It's not to say that the service network owner or the service network admin can't go later and adjust things or talk to folks and get things changed. But it really comes down to that, right? Whereas when you're looking at VPC Lattice, a lot of that is core, and no matter what the service teams want or the application teams want, whatever's set on the network is set on the network. Now, when it comes down to being more application aware, I mean, realistically, if you're looking at cloud networking, as opposed to, say, traditional networking, cloud networking is all about supporting the workload in the application. So there should be a little bit more awareness in the networking teams when you're working in cloud. It just really should be. But that being said, if you want to be so staunch and you're like, I only want to care about my things, set up the service network, trust your service owners, and then they can set up their policies, and then things can roll well. It'll actually be a lot easier on the networking team, realistically, as opposed to doing, say, a VPC Lattice, where, as you mentioned, Tom, like, hey, every add, move, and change, the networking team has to get involved, ask all the questions, make sure that the InfoSec team is happy with whatever change they have. So again, it's a bit more organic. If you have that trust in there, you should be good to go. That's generally the way I look at it.
Got it. And then probably looking at the time, one more quick question. That's more a little bit under the hood. I don't know how much we can share here, because
I can share a little. I'll share a little
yeah.
bit. So basically, when you look at the fabric of our hyperplane, when you're talking about things like transit gateway, IGW, network load balancer, and transit gateway, VPC Lattice kind of has its own, more similar to an ALB or an elastic load balancer. They will run on top of the hyperplane, but it isn't the same thing. We use different types of technologies. And that's mainly because the standard hyperplane that you all have heard about and all the reinvents for all the networking stuff has its purpose. And then the Lattice purpose kind of bolts on top of that. We do use some of the pieces and it does interleave, but I want you to think of like the ALB hyperplane and then the standard networking hyperplane, and they mesh together, and Lattice is somewhere in the middle.
Yeah, I think the important point out of that is also that if you see a single network interface for an endpoint for Lattice, that is not a single point of failure, right? Just
Correct.
like
Yeah, it's a good point.
because that's ultimately what Hyperplane was doing, where we were able to show, hey, you have this one network interface representing a load balancer, not gateway. But ultimately, under the hood, it's just a software-defined mapping, and there's actually a fleet of components delivering the function, and each one of them could fail, and that's not an issue. We can make sure to distribute the traffic. So that same logic applies to Lattice.
Yeah, just to blow all of your minds, our hyperplane runs on compute, right? So it's not a bunch of switches and networks and stuff. It's literally our own compute that actually supports it. Now, of course, we do a lot of stuff in hardware and in chips, but you need a processor somewhere, right? So, okay, moving on. I got too many slides now. Okay, so if we're going to compare the two now, I'm trying to accomplish the same thing, right? I need to give service to service communication in the transit gateway. I'm using ALBs, right? And each ALB has its target group with a bunch of targets. They could be Kubernetes clusters. It could be whatever that ALB support. And I'm doing the same thing over in VPC Lattice. And you'll notice there's a couple of differences right off the bat. Each of the services in Lattice is actually a defined service. I'm doing a little traffic shaping, as I mentioned before, which I can't do on the transit gateway. But essentially, right now, both of these architectures are doing simple, boiled down. I don't have IGWs. I'm not talking about VPNs. I'm not talking about direct connect. just getting my different services and different VPCs to talk, this is the same thing. Now you'll notice that I got a bit of a headache when I was looking at our pricing calculator. I know there's a lot there, but I tried my best again to do a very simple, I'm processing like 200 gigs. I've got it split up 4 ways, 50 gigs between each of them. I've got 5 rules for each of my ALBs, 1 second for my connections, 50 gigs processed, 25 new connections at a given time, holding 15 connections at the same time, right? Price that all out. And I did the exact same thing over in VPC Lattice. And you can see, because of the fact that I need less in Lattice, and because Lattice is pretty much built out more as an application networking construct, I need less things and it's cheaper. Right. And now, granted, again, I know that Tom covered some pricing things before, but I want to just highlight it again, that the way that you're going to get savings in Lattice is you're going to have to take away. It's going to have to re-architecture if you already have a transit gateway. Right. So if I were to just put all of my ALBs, right, over into the VPC Lattice side, obviously the VPC Lattice would get a bit more expensive. I think it's still a little cheaper, but it's not needed. But the real power of Lattice is to leverage all of its features that it has. You can certainly have in all of your services anything that overlaps. Again, I can have an NLB in there, I can have an ALB in there, but you really don't need to. So when you're trying to use Lattice in your architectures or move to Lattice in your architectures to save money, make sure that you're looking at the full capabilities of what Lattice can do and what you can remove in your existing architecture to see those savings.
There's
And
some
it's easy to manage.
questions. Yeah, that's Jamie. There's a question from Kareem again on like, are customers like going all in with Lattice? Like, are they
Yeah.
completely running
Yeah.
everything with Lattice? I've seen both. Like for
I've seen, yeah,
most
go ahead.
customers, it's going to be an end, right? You can't just throw out immediately all of your architecture. It's a big project to move from one network
Yes.
architecture to another. They can take months or years sometimes. But I've seen like Lattice. That's why we want to spend time today on some of those use cases, because the one that you're explaining, Jamie, right? You can have start with the TGW on the left, and then application by application, move those to Lattice running in parallel while you're
Correct.
keeping your TGW infrastructure. And for every flow that's moving onto Lattice, there's a potential cost saving because you're removing the requirement for being processed on the transit gateway, on a load balancer. If you have
Right.
inspection in there, that would be additional cost associated with that TGW flow, right?
Correct. Correct. Yeah. And so what I've seen is, and I'm going to be very, very blunt about this. The more modern of an architecture that a company has, and the more modern of way of thinking, like using Agile and Scrum and all of that, and developing their software, the easier it is for them to adopt Lattice, right? If you're more traditional, more waterfall, more segmented, it will be harder. But I have seen customers that are more modernized, some very large customers that we all know the names, where once they got it, where that light bulb went off in their head, they're like, okay, I want to move this. Okay, we need to have 6 more meetings. Let's do a couple of workshops. Can you say the same thing you said here to this group so they get it? There are those folks that are doing it, and they are going to be leaning in and going and moving whole hog into Lattice. But that doesn't mean, as Tom mentioned, they can't get rid of the transit gateways, right? Because they still need to have their central connectivity to their data centers, and they still need their cross-region connectivity. There's still some folks that are doing SD-WAN. So you're not going to get rid of the transit gateway, but once the Lattice concept is absorbed, I do see a lot of people kind of going fully that way. And that's really unlocked with the conversation of, hey, Lattice, it doesn't do everything, but what it does do, it does very well.
Mm-hmm. And then there's another question, if you go back a second, related to performance. Like from a performance perspective, what are the considerations here? How should we think about performance? I'm curious about
That's
your
a
thinking.
great question. That's a great question. All right, so there's a couple of things that you got to really consider between Lattice and Transit Gateway. For Transit Gateway, you can get very particular, like making sure you're keeping everything on the same AZ, right? Making sure that you have strong throughput, but the edge or the attachments are still 100 gig, right? And it's the same for VPC Lattice as well. So for the two of them, at the base level, they can run just as well. But remember, Lattice is a proxy, right? And you can add listeners and rules and all these things to your individual services. And the more complexity that you add to those rules and the more things that you have to go through, that's why you want to make sure they're streamlined and not just bolted on all the way through. the more you can cause some latency. We're not talking huge latency, but sometimes if you do that, those circular rules that sometimes you can get, it will hit your performance. So in general, if you tune your services, if you tune your access, if you have your policies set up correctly, you shouldn't see any deficit in communication between your services from when you move from VPC Lattice to Transit Gateway. Now, keep in mind when we're talking about doing like really advanced networking, I want that 400 gig, all the stuff that really gets Matt really excited with the high performance VPCs. That's still going to be restricted inside your VPCs, and you're going to be using things like VPC peering. So in that regard, I wouldn't look at like if you're doing ticker tape kind of stuff. I would start looking at a little bit of a different architecture, even away from VPC Lattice, at least for those instances where those workloads are in.
Cool. There's one other question I want to bubble up from Kareem about
Sure.
tracing. But in the meantime, we also have our product marketing colleague Anusha here in the chat. So she'll be going to be popping in every once in a while a link to a case study or some relevant link. So if you see updates from Anusha, just know this is our product marketing person that's helping with Lattice product marketing.
You say hi to Anusha, everybody.
Yeah, she just shared a case study that might be interesting to hear about a particular customer using Lattice. But going back to Kareem's question about tracing, so that's moving on to the visibility. I guess that's
Right.
more deeper on Lattice itself than Transit Gateway. Do you want to comment on that, Jamie?
I'll comment on it, but I'll also say that Tom should have covered this. I'm kidding. It's a total joke. But yeah, no, again, remember that the VPC Lattice is going to be aware of all of the different services that you have. And so when you're looking at your access logs, just like you would from like say an ALB, that's pretty much how you're going to do your tracing and your access connectivity. That does not rule out, by the way, any of the network level stuff within the VPC with VPC flow logs. As Tom probably covered last week about the link local address and the 162 right? Addressing, I touch about that a little bit too, if we can get to it. Those are still in your VPC flow logs. So when you have a service or something talking to the unnumbered ENI that Lattice uses to connect to your VPCs, you can still see that. And then you jump over to those access logs. And that's why I made that comment earlier for a lot of the tracing is that you want your VPC Lattice and your networking construct logging all going through CloudWatch to get to like an S3 bucket that you can look at with your SIM, you can look at with X-Ray, you can use whatever tools you want to dive in. Make sure all your timestamps are set as well. And that will really help you with your troubleshooting and your diagnostics.
Sounds good. Thanks, Jamie.
Okay, let's go on to the next slide. Okay, so IP overlap. Now, this is a big thing to understand. A very smart friend of mine had once said, Jamie, the way we're approaching Lattice is probably a little too complex. We want to go with what will be the easiest workloads that we can talk about to get people to understand. Yeah, it's Tom. He's like, let's go about the easiest workloads. And the number one workload that I've been finding talking to some of our customers is IP overlap. Right, IP overlap is a big problem, especially with acquisitions. Within the times that we're in today, you'll see more and more companies kind of buy out other companies, and then they all have AWS infrastructures, and they all have the same IP addresses. So Lattice is a good way to bridge that gap as easily and as comfortably as possible. But I wanted to say, how is it possible, and what is possible, and why? So this is one of those slides that's going to talk about how overlap works. This is very similar to what Tom was mentioning. But the first thing that you have, right, is you associate your VPCs. And we're talking about using basic Lattice, non-endpoint services, HTTP, HTTPS, gRPC connectivity. So you basically have your VPCs associate, right? The next thing that you're going to do is you're going to get your link local addresses. That's the 169 addresses. These are the non-internet routable addresses that will appear both in your ENIs, and then you'll see the networks actually show up in your routing tables as well. There's another network that shows up in your routing table that's related to Lattice that confuses some people. That's the 129 network. I didn't put it here, but I'll just mention it anyways. That's the actual IP address range of Lattice itself. And the special thing about the 129 network, it can't be routed. And the main reason why we use that for Lattice is so that nothing can break into Lattice. It can't go out through a different route. The only way it can communicate is if it actually lands in one form or another through a construct into each VPC. So it was a decision we used to make it more secure. So if you do see the 129 and say, what is this? Don't delete it. It's your Lattice network. And it's basically there just for link local connectivity, not for routing. And then the last thing is you get each service gets an FQDN, right? And those FQDNs, just like we do with the gateway endpoint for S3, when we see that there's a call, it gets usurped by DNS, gets shoved through that link local address, right? And then goes through Lattice, and then Lattice evaluates where it's supposed to go, all the routing, all that fun stuff. So that's how IIP overlap is achieved, because we're not doing this through like an IP address of an endpoint. We're going through the link local, and we're actually addressing each of those services that are registered with Lattice via their FQDNs in this manner, or we'll do it through a resource config, resource gateway further on.
So Lattice, you connect to the Lattice IP network, and then you see the connection to the application also from a Lattice IP network. So you're ultimately hiding the IP addresses of these VPCs between those
Correct.
VPCs. So
Not needed. And so in this example, what I have, and this is actually from a direct customer, they had 3 accounts, right? And each of the accounts, they wanted to basically connect up a particular service. And they wanted to have these different services talk back and forth in a bi-directional manner. They're originally going to go with firewalls and have to worry about their security groups. So then we're like, hey, you could just simply use VPC Lattice for this. They're all in the same region, right? So what we did is we said, okay, create your service network. Then all you have to do is share that service network via RAM to the other accounts. And then from there, we declared our services and then set up our configurations to talk. And then they can go ahead and set their policies through IAM for their roles and responsibilities, which they did. And they were able to, again, within the same region, speak to these 3 different VPCs. And yes, these 3 different VPCs were associated to 3 different transit gateways. So this is an example of where I have multiple workloads. There's a transit gateway involved. This literally could be the same transit gateway if we really wanted it to be. Like have all 3 of these VPCs on the same transit gateway and then just specially connect their services with Lattice. But in this example, they had 3 different lines of business. They had their own accounts. They had their own billing, and they wanted to set it all up. But the thing to mention is account A, somebody has to own the service network, right? So that was the biggest fight that they had. Who was going to own the service network and set that policy? After that, everything worked pretty well.
I just realized that in your diagram, you actually have those VPCs connected to the transit gateways. When you show the slide, I thought this was a very fancy background color scheme,
Okay.
and then I'm like, oh yeah, these are just transit gateways, but they're very big.
Yeah, they're big. I mean, I was going to do a bunch more, but I ran out of real estate. So that's good feedback. But what do you guys think? Do you think I should keep the transit gateways as big as they are or shrink them down?
Make them bigger, dude. Make them
Make
big.
them bigger. So then we're going to cover over the last piece about before we get into some crazy architectures about layer 7, right? Because a lot of folks are still saying, hey, Lattice is only layer 7. I can't use it. Well, you can use it now with the service endpoints, and that adds on layer 3 and 4. And I'm going to cover over like what it is and how that works, again, in reference for our architectures. So if I've got on my right-hand side my resources, right, and at the top and my left, I have things that want to consume those resources, how can I get those resources shared over? So what you would do is you would have a resource config. That resource config will have a bunch of entries. You can do just a config with 1 entry, or you can do a resource group, which I have here, where I have 3 different entries. I have an FQDN, or fully qualified domain name, that reaches a website on the internet. If you're using an FQDN, it has to be public. I think, Tom, you probably mentioned that last week too, but it has to be resolvable by the resource endpoint service. I've got an RDS. I'm using an ARN here. So the benefit of using an ARN and an RDS is that as the RDS expands and contracts, it will automatically add the children of all the new nodes into your resource config. Otherwise, if you're going to be using, say, an IP, which is the last one, and you add more IPs to that resource, you have to go and add those children in manually yourself, either using Lambda to automate or whatever. So now I've got all of those into my resource config. My resource config then gets associated to a resource gateway, which I have here. And then from there, I can go ahead and attach that resource gateway or associate it to my service network. So my service network can gain access to those resources, or I can have access within my subnets through a resource endpoint. One thing I want to point out, which is a nuance between private link and resource endpoints, and the reason why I'm calling them something different other than just a VPC endpoint, is that you'll see that I have 3 resources in my resource config. That represents, if you go into the resource endpoints within your console or do a describe call, you can see that under the associations, you'll have 3 separate FQDNs for each of those services. So if you guys remember like the sub-interface game, like with Linux or within routing, if you're creating sub-interfaces, we're kind of using that same methodology in the resource endpoint. One endpoint, multiple IP addresses, or as many as we need to reference all of the resources on the right. And then the last thing that you can also do is you can put a resource config into your service network and then have that as a service network endpoint in a VPC as well. So then you can gain access. And we do that in a very similar way. You'll describe what services are part of that config, and then you'll go ahead and share that out and allow that connectivity to come in. So that's pretty much how the endpoint services work in a nutshell. So now let's look at some use cases and see where we can go. So here's one that I had where a customer came up and they're like, hey, we have multiple accounts and we have one account, and all it is it has all of our resources. It has all of our databases. And they literally put it in just one account and controlled it. I think they were doing it for price control, a resource controlling to control access. And they're like, hey, can we use this Lattice as opposed to using a bunch of NLBs, which is what they were doing in the past, and doing a bunch of manual entries and lambdas to track their RDS growth and shrinking, as well as their own personal databases. So they said, yeah, sure. What you could do is you just basically get your resource gateway, as we described. We have our resource config. We set up an ARN for all of their different databases, and then we shared it directly to their service network. And because it was shared to their service network, and they had the policies in that set up correctly, everyone who was participating within that service network did have access to those resources. So it was a way to do almost like a centrally shared database across multiple accounts.
I think that's a popular use case with our partners and independent software vendors that deal with data.
Yes.
Right? You can imagine there's a list of vendors that do a lot of stuff with data analytics. Very often they would do that, have deployments where they're running compute in their environments, but they need to get to the data that belongs to their end customer that's on AWS. We didn't really have a great answer on how to solve that, right? They ended up forcing the end customer to put an NLB, create a private link service, and as you explained, Jamie, track IP addresses. So now you just have a way to expose any resource inside of a VPC to anybody else in the same region.
Right. Now, and you can also imagine that originally what they tried to do is go out through an IGW through a VPN, and that was just cost prohibitive for the amount of data that they were transferring. Remember, Lattice is fairly cheap in terms of its data processing and what it needs. So that also cut down the price on that as well. And then also sharing through RAM, when you're using a resource access manager, you have a lot more dials and knobs in terms of what you want to share and how you want to share it. So it gave the database owners a little bit more confidence to go ahead and share this out to these service networks. Or to the service network. Yes, the line is going behind. It's all one service network. It's not two, but I do get into an architecture where we do have multiple service networks as well. So if we're moving to the next one, here's one with multiple shared resources. So this was all actually within the same account, but you had like two different types of networking groups, or two different types, not networking groups, but two different types of groups. You had your application owners and your service owners. So I would call that the transit or the VPC Lattice group. And then you had another group that was not really associated with any of that, different line of business. And one of them ran a very specialized, centralized website, right, which was using Lambda, and it had some auto scaling groups and some IPs. And that's the one you see on the lower left. And then, of course, the standard database one, right? And they both had to share it back and forth. And then, oddly enough, between the two lower VPCs that you see here, they got rid of their connectivity between those two VPCs because it wasn't needed. This was considered a big contention for them because it was a peer, right? And that peer was bidirectional. They had a whole bunch of firewalls back and forth, on either side. They were actually not even using ANF, they were using gateway load balancer. And then they were, upset about some of the costs from some of the partner firewalls just to secure these down. They didn't trust just using security groups, but when they saw the policies that you can do and the way that you can lock down with roles and policies, they're like, this we can accept. We can export these policies and give them to our auditor and say, this is our firewall. And it was just a much easier way for them to communicate. And it was a lot more simple because all they had to do was just maintain their resource configs. And the service network folks, the service network admins, all they had to do was maintain their overall overarching service network policy. Generally, we want that policy to be more macro, but they were a little bit more micro with this one for good reasons. And then, of course, the individual resources had their own. So that all worked out well. So the next one that we have is the third party, right? This is getting closer to what Tom was saying with some of our data folks, but this was a little bit in reverse. The reason why I wanted to put this up there, there was a company that had a third party group that would come in to their database and massage their data and then put it back into their database, right? So originally what they had to do is they did bidirectional private link. And I don't know if any of you have ever gone through that fun. It's like twice as much as what Tom just mentioned on the complexity of private link. I have to set up an NLB on both sides. I have to set up my target groups for the NLBs on both sides. And then I have to set up endpoints on either side. And then I have to make sure that whoever needs to talk to each of those endpoints are doing it correctly. And they were sharing things like CloudFormation scripts back and forth. And then they found out the other team didn't even use CloudFormation. They used Terraform. It just became a mess. So when they landed on using Lattice, they were like, okay, what we're going to do is we're going to basically share out. The provider actually had a Lattice service network already, and the consumer had one. So they basically shared things out using the resource gateway, using RAM, sharing RAM to their service network. Then they went a little farther and said, hey, we could do a couple of different communication paths within that center service here. So the provider actually shared out, again, with RAM to the customer, some service network endpoints, allowing for their workloads to go ahead and communicate directly with some of the compute within the provider account. So the provider account was doing two things. They were accepting control and config, right, from this center VPC here. And then based on that control and config, they went through and massaged the database after pulling the data, massaging it and pushing it back. So at the very base, this looks like it's a kind of a simple architecture, but it actually solved a very complex goal. Because again, with private link, how am I going to do this? I'm going to put an NLB here, put endpoints down here. I put an NLB here, endpoints, NLB here, endpoints. And then all these NLBs and all these target groups had to be maintained. It was just too much. In this paradigm, all we're doing is with two different service networks, sharing out service network endpoints and then associating a resource gateway. And we get even more fun. I already showed the multiple service networks. I should have probably put this slide before because it robs, all the thunder is robbed in the slide beforehand. But again, I just wanted to kind of highlight that even though we look at a service network supporting multiple services, and those services could be disparate, right? Because you can have multiple roles and you can have multiple policies. There are times when we've had some customers need to use more than one service network. A different line of business had a different service network, but there's somewhere they had to meet in the middle for whatever reason. And this service network here on the right, this was for a customer that was in the private, in the public sector. It was a government. They were doing pretty much strict HTTP, HTTPS here. And the main reason is this communication on the right, they wanted the most secure communication path. And if you're using just link local and not IP, this is the most secure path that you can do. Remember, I told you the addressing of the Lattice network being the 129 internally, not being able to be routed. They trusted that. They had their policies all set up. And on the left-hand side, this is a little bit more open because you're now getting a little bit back into that perimeter networking with the service network endpoints, right? So the service network endpoints do have their security groups. They're relying on the default security groups of the VPC. But there is that interface of traffic leaving Lattice, going over a hyperplane, and then back into another Lattice through this service network endpoint. So that's another possibility.
So we were just chatting on the side with TechFueled about the use case where you said a customer had to decide which account owns the service network.
Yeah.
You could have more than, that was suggestion from TechFueled, you could have more than one service network. Everybody has their own service network.
You
Right?
can do that.
Yeah, and then they just use service network endpoints, just like you're showing on the left, to have all the VPCs to be able to talk to all the other VPCs.
A friend of Tom's and mine too, Scott, also likes to use this paradigm to be able to do cross-region, right? I don't have a cross-region architecture here because honestly, I haven't worked with many customers to do it, but it is possible to do the bubble bridge as well, right? Where you can also say, hey, I need to get access to this service network over in another region, put up a VPC, make sure that you have your VPC peered because of the service network endpoint being an endpoint, having and consuming local IP addresses, they're routable. So yeah.
Cool. There's some interesting items in the chat. Maybe let's tackle them
Sure.
bit by bit, right? So Kareem is asking about the policies. I believe today the IAM policies that you mentioned, Jamie, are only for services, right? So if you're accessing resources like SQL databases and it's TCP based, today we don't yet support policies on resources. The IAM policies are only on services. So I guess for the access to the database that we discussed earlier, you would primarily need to, first of all, enable it or make it available as a resource, but then make sure you configure security groups accordingly to allow the communication to happen.
Absolutely. Yeah, absolutely correct. The security groups are still valid. And remember, once you go into TCP land, right, that's when we go back into venturing into the traditional networking, the perimeter security, and the policies. It doesn't mean that we're not working on something, but it's a tough nut to crack, right? Because there's a lot of moving parts. We need to make sure that we don't compromise any type of throughput when you're doing policy-based networking. It's easier for us to do it in layer 7 because you have headers that you can control. There's a whole bunch of information there, but we don't have those HTTP headers when we're going into a database. So we have to figure that out.
How do you deal with, like, because with layer 7, you sign with signature v4, right? So with traditional IAM way of signing a request that goes into an authorization header or SIG-v4 header, and you're golden, right?
Yeah.
And how do you do it when there's no headers? You don't even necessarily are carrying a HTTP application. This could be any kind of TCP application. So
like
interesting,
FTP?
interesting not to crack. Yeah.
Yeah.
There's some other comments here. I think it's interesting one that does bubble up every once in a while from Ken on like dealing with how would you add WAF, right? And Curious Orbit mentioned that they're actually doing something like that in their environment. So I'd be curious Orbit, if you want to pop a message of what you guys are doing, because that is interesting. And I think the way I would do it is I would put an ALB behind a resource and put WAF on the ALB, right? So that's how I would do it.
It depends. You could also do it, remember, with API gateway. It really, because it comes down to if you want to offload your load balancing, because ALB is, obviously an excellent load balancer, and it's one of the things that Lattice was modeled after. But if you don't need that, you can also do like an API gateway and just do a pass through with HTTP, HTTPS if that's what you're going for. Because remember,
that would be API gateway on the front end, because you could put the WAF. It would either be on the front end, so when you're hitting an API gateway and then you're saying point to Lattice. Is that what you're saying, Jamie?
Yeah. Or the reverse, where you have the API gateway and then your resources are behind it. Like say if you have a bunch of lambdas or something like that, you can point the API gateway to that.
Yeah. So, but then your API gateway, like pointing API gateway to Lattice is pretty tricky, because Lattice, even endpoints, IP addresses will change. So you need to account for that, or potentially can change. So they're not forever static. So that creates some complexity there on like front ending a service network endpoint representing a whole service network. But it's an interesting comment here from Ken about you could actually present an ALB as a DNS-based resource behind the resource gateway. That ALB could be running WAF, and that could be your thing that you're exposing. So if you really need to add WAF in the path, you can. I guess I would probably then not expose it as a resource. If I know it's this HTTPS application, I would expose it as a service. I could still put a load balancer behind it if I want to, but like Lattice can load balance for me. So the additional value is purely the WAF. And then the question on the WAF would be, what is it that you're actually doing? If all that you're doing is you're setting up, I'll allow this IP address to talk to this IP address, Lattice is giving you that out of the box. But if you're doing like SQL injection, cross-site scripting, like something deeper, sure, it makes sense to have WAF somewhere in the path.
I mean, it really depends too. It goes back down to that trust conversation, right? If this is all internal, and if you're worried about cross-site scripting, I think you have a bigger problem than whether WAF will work with. But just kind of looking down at what Curious Orbit was talking about, I've seen that before, and maybe I should have built a reference architecture on this, where you're actually putting WAF on your ingress. So a lot of folks will use ALB. They'll add it to, say, let's say we add it to service one here in an ALB, and then there's access to the internet, and the internet comes in through the ALB. Because right now, Lattice doesn't have any form of internet gateway, if you will, or internet access. So you have to go through one of your services. And it's really good idea to designate one of your services or a service to be the ingress service, and then divorce anything that you need that has to be secured to other services. So that way you can use the security of WAF when you come in, your security groups, and then when you get into the Lattice network, you can be very prescriptive over what headers you'll accept, what roles, all of that, so that you can have that extra layer of protection.
Yeah, for your traffic coming in from the public side, you definitely want to have a WAF, right? That's
Absolutely.
absolutely have a WAF there. That is stuff coming from an unsecured side trying to get to your applications. You want to have as much security as you can. But once you're in, then talking between applications, I agree with you, Jamie. Like if you're worried about cross-site scripting between your own applications internally, you probably got bigger problems on your plate than wanting to put
Yeah.
WAF in that flow. But I still get it that centralized teams want to have additional visibility, want to put things in the middle to see what's
Mhm.
going on. I guess they would have to rely on Lattice logs to be able to get that extra
Yeah,
visibility.
that's what I was going to say. One thing that folks do use WAF for, outside of security, and sometimes I've seen it where they've only used it for this, is just for the metricing, right? How many requests I got, when were they dropped, where they're coming from. That's very rich. But keep in mind, Lattice can tell you a lot of that stuff as well. So if that's what you're looking at doing, using WAF just for the reportability, absolutely 100% on your edge. But if you need to do it for your internal application or your service mesh reporting, look at the capabilities of Lattice logging first. Because WAF, honestly, too, keep in mind, we charge after 4 rules, right? It does add more complexity to your, anytime you add complexity to networking, you're going to take a hit. You got to pay that piper somewhere. So on to the next architecture that I've seen, we have 2 different service networks, which is pretty cool. So it's 2 different organizations, and they have a corporate data center. They have on-prem in the mix, and their on-prem had an Oracle database that they wanted to get access to, right? And they wanted to share it between both of the service networks. So what we did is we told them, okay, use a resource gateway. The other trick too, this is a big thing that I've come across every now and again, is that they had routable IP addresses. So some of these older, larger companies will actually have routable IP addresses on their on-prem, like literally assigned to their workstations. And that's what they had here within their data center. And as you know, as a general rule, like say if you're using a network load balancer and you want to use private link, the owner of the NLB and the owner of the CIDR range have to be the same for us to allow list that. And that's not always the case, right? And people are like, what can we do? What can we do? So what we did is we're like, okay, create a resource config, right? Add FQDNs from, it has to be publicly resolvable, remember, but the routable IP addresses were not resolvable on the internet, so it wasn't like they were going to go through some back door. They added it into their Route 53, right? And then they put the FQDN from Route 53 into their resource config and then bound it to the resource gateway. Then they associated the resource gateway to their service networks. And remember, I'm saying networks as plural, because 2 different lines of business needed to have access, and they both had their own presence in AWS. Oddly enough, they were both in the same account. They didn't split their accounts up, but they did have 2 different operating groups within there that wanted to have access to those databases, and they didn't want to cross anybody else's workloads, right? So they wanted to keep it separate so that, let's say, the red service network, if they did any add moves or changes, it wasn't going to affect the yellow service network. So that was kind of their use case, and that was cool. And I go in a little bit of how we did that. So this is the same thing that I've shown before to others, but you need to have Route 53 endpoints. You need to be able to resolve to your on-prem, right? So have all this working together. And then what we did is we stuffed, whatever.com has to be publicly resolvable into Route 53. And then we added multiple IP addresses to it because they were basically doing a round robin spread. In their database new state with each other. It's Oracle database. It can do some crazy things. So they literally turned Route 53 and resource gateway into a load balancer. And they were load balancing across load access to various resources, database type resources that were aware they were all clustered back and forth. So it was fine on-prem. And that worked out quite well. Yeah, so there was that too.
All right, Jamie, quick time check. I know we're
Last slide. I'm on
okay.
my last
Wow,
slide.
I'm impressed. I'm
Yeah.
impressed.
So then we had another company that I was working with, friends of ours. They are not using managed Kafka. They're using their own Kafka on site, but they wanted to centralize it because if anyone knows Kafka, and I got a little bit into the weeds with Kafka, I'm not a big Kafka nerd, and I'm glad I'm not, because my God, that the amount of things that you can tweak and how many different ways you can go crazy configuring this. So their use case was this. They had, again, same thing, a couple of different service networks, two different groups. They wanted to use Kafka differently. One group was basically pushing data into Kafka, and the other group was consuming data from Kafka. So what we did is we created two different resource gateways, and we put the IP addresses for the different consumer groups into the individual resource gateways, and then just allowed access between those gateways for whoever got access. So if I'm going to go back one more, the way that these two service networks are accessing Kafka are different ports, different IPs, because of the different functions. And you'll notice the red, because of its resource config, isn't accessing Kafka the same way as yellow. So there was a definite delineation, which gave them the comfort to centralize their Kafka. Right? Because before, their big nervousness about Kafka is, if that thing's gone, it's a big problem for them, right? So they wanted to centralize it, but it's their baby. So this is how we managed to do it. We gave them two different points of access, and that's pretty much how we centralized it. Now, yes, we do have MSK, right? We have managed Kafka service in AWS. We are very aware of the fact that the managed Kafka is a little bit more difficult with resource gateways and with Lattice, because of the DNS names that they will create. Once the Kafka cluster expands, more DNS names are created, and you have to manually enter those, and you have to catch that they've been created and enter them into your resource config. If you are using managed Kafka and you want to centralize it, talk to your account team and get that PFR set up, because our PM badly wants to make it so that you can address or contact Kafka just like you would Route 53 through an ARN. So to get that enabled, we need the voice of the customer to say, this is something that we want. And now, I think with 3 minutes left, I was really nervous that we weren't going to make through, but I guess we did well.
We didn't make it last week. We kind of I really had to jet through some of the slides. We'll come back to them. We actually have two more sessions on application networking. Next week is going to be the demo with Alex, and then the last week we're going to touch on some of the topics that we maybe weren't able to touch on. And if you guys have any suggestions of what was the most interesting out of the series, if there's anything we can whiteboard for you on the last day, any use cases, let me share the survey in the link here, and you can populate the surveys. Let us know what is it that you need. Survey.
And if there's any type of use cases that you want me to diagram up and then make sure they're a part of these presentations, or something simple or something very complex or whatever, have your account team get in contact with myself or Tom, and if it's allowed, let's get it out there. The more disparate use cases, I actually had cut out 4 other use cases because I knew there was no way I'd have time to do them, because they were getting crazier and crazier in complexity. But yeah, if you have any, please, by all means, let us know.
Cool. All right. Thanks, everybody. Thanks for joining. Thanks, Jamie. And we'll see you guys next week.
See ya.